Okay, so we have talked about geometric vectors, and that's when we were doing like a tip to tail thing where we would take one vector, add the next vector, find our new vector, and then you could measure the angle here and the distance here with a ruler. So now we're going to talk about doing them algebraically, assigning numbers to them, and finding out where they are. So we can use ordered pairs to represent vectors, but they kind of have pointy brackets like this. So this is how we know it's a vector. It has those pointy bracket x comma y, where x is the horizontal component. We talked about that last time. And y is the vertical component. And that makes sense because you would move x in the x direction and y in the y direction. So for example, if I had a vector 3 comma 5, it has its initial point at 0, 0 at the origin and its terminal point where it ends at 3 comma 5. And now that's a point. So if I start here and then I go 1, 2, 3, 1, 2, 3, 4, 5. This is a vector. This is the vector 3 comma 5, meaning that it goes over 3 and up 5. I know my lines are a little bit off, but I also could make another vector and it wouldn't matter where I chose it. If I started here, 2, 3, 4, 5, and drew this vector, the address of this vector would also be this because it's over 3 and up 5. So we can describe any vector, over 3 and up 5 as these pointy brackets 3 comma 5. Okay, so if we have an initial point and a terminal point, meaning where it starts and it ends, I'm going to give you the initial point, x1, y1, and the terminal point, x2, y2. The ordered pair, and I'm going to do it like this, the ordered pair in pointy brackets that represents the vector, which would be P1, P2 would be this vector that we're representing, it's kind of like the distance formula. We just subtract the points. And I'll show you, for example, up here on my red line that I had before. So 1, 2, 3, 4, 5. This was over 6 and up 1. And then this was 7, 8, 9, 10, 11, 12, 13. I'm sorry. 1, 2, 3, 4, 5, 6, up 6, 9, comma 6. Sorry, that mine got crowded. The ordered pair in these pointy brackets that represents this would be 6 minus, I'm sorry, I need to do my x's first. Let me erase this. In the x direction, we would do 9 minus 6, and then 6 minus 1, and notice that's 3 comma 5, which is exactly what we have up here. So to find them, I think that sometimes the formula is tricky and like we don't remember. You can always count these pieces out. Like I drew them up here. I counted over 3 and up 5. You can make a triangle out of any of them and count over and up and find the components. So it's kind of nice if you forget the formula. So similarly, to find the magnitude of our vector P1, P2, or the distance from example, the point 6, 1 up to the point 9, 6 would be like the distance formula, which really just comes from the Pythagorean theorem. You would square root all of this. It'd be all under the square root. So instead of scrolling back up, I'll put this one back on here. So what did I have? 6, 1, 2, 3, 4, 5, 6, 1. So here was my vector, 6 comma 1. And we found the address or the pointy vectors. How do I find the magnitude of this vector? I would take 3 squared, add 5 squared, and then take the square root of it. That's the Pythagorean theorem. And sometimes it's called the distance formula. And they're both the same thing. So again, I'm giving you this formula, but you don't necessarily have to use it, right? Because the distance of this one would be 3 squared plus 5 squared, 9 plus 25, and that is 30 square root of 34. So that would be the distance here on this triangle. The other thing I want to talk about is just vector operations. Okay, I can hardly read that. Vector operations. So when you add vectors, vector A plus vector B, you take their components, A1, A2, B1, B2, their components, and just add them together, just like you'd think you would. Add the A, add the first one, and then add the second part, the X's, and then add the Y's. So what I like to do, though, is when I have an X, Y, I like to stack and add because I get mixed up. So like I'd have 2X and 2Y here. It's a comma. Stack and add, that makes way more sense to me than trying to add across. So if that helps you, please do that as well. Subtraction, just as you think it will be, should be a minus, is, if I have my same vectors, I subtract the X components and then subtract the Y components. So again, what I usually do is I take my, and instead of subtracting, I add the negatives and I stack and add straight down. So I flip the sign and add. And I think I kind of showed you that when we did this. I said this was the positive version of A, but when we were subtracting, you just made it negative and then added it. Same thing, make it negative and then add it. And then the last one is going to be scalar multiplication. That's what it's called. So if you have some number k, remember we call a scalar k times your vector A. You're going to take k times both components. And you're going to get, just like you think it would be, that number times both the X and the Y. Okay, so I think you should be able to move about the next homework assignment, and what pages it is on your calendar.